Hello everyone and welcome back. I would like to start off by saying that if you made it all the way up to this video, I am really proud of you. Well done. So in this video, I'm going to kick off the final big topic of this lecture series, which will be about continuous systems. So that means that by all the previous videos, we concluded the topic of discrete systems. So these were systems with a finite number of degrees of freedom, typically cards or penduli or disks connected to each other or by the fixed world. And their degrees of freedom can be stored within a vector, and they are a finite number. Okay, so we have coordinates x, y, and theta typically. Now, we know how to derive equations of motion of these kind of systems, and we are able to determine natural frequencies and modes. And we have seen in the very last block actually how, by using modal analysis, we are able to derive the free and forced vibration responses of such systems. So in the next block, the continuous systems that we are going to look at, they are fundamentally different in the sense that the number of degrees of freedom is in a certain way infinite. We are not going to be able to describe the system by just a vector of coordinates, but we need to describe deformations in terms of displacement fields. So the typical continuous systems that we are going to look at are vibrating strings, bars, shafts, and beams. So these are really structural elements. They may make part of a structure typically. And most likely you have already seen equilibrium analysis of these structures before. So think of a course like mechanics of materials or elasticity theory, where we look at the deformation of a structure as it is loaded externally by static forces. And we were able to describe the deformation as well as the internal state of stress. Now you can imagine that in reality there are a lot of situations where these external loads in fact change in time. And that's why we need dynamics there. So how can we describe, for instance, the deflection of a beam in bending as a function in time as it is subjected to external loads? This will be something that we will work towards. Now, you will see that the fact that we need to describe a displacement field causes the equations to be solved to be partial differential equations. There will be derivatives with respect to time because we have something like acceleration, second time derivative. But we will also see that there are derivatives in space, and they depend on how much, what is the slope of the deformation, what is the curvature of a beam, things like this. So that would make the math initially slightly different. Now, what I will show you is that basically the mathematical skills for solving these partial differential equations, these PDEs, they are such that basically we use trial functions that cause the equations to reduce to a set of ordinary differential equations, of which we know how to solve them again. So for all these structures, I will show you how to determine the natural frequencies and modes. And I will show you as well that using these natural frequencies and modes, we are able to establish a set of modal equations, which are second order ODEs again. So once we arrived at that point, we can use all our knowledge of single degree of freedom systems again in solving these equations. So I will consider four kind of structures, as I already mentioned. The upcoming block is about strings, vibrations in strings. I would say this is not really a structural element, but from a didactical point of view, it's interesting to start with vibrations in strings because yeah, we are really familiar to it in the sense that we all have seen a guitar or a violin at some point. So we can kind of imagine what is going on in these vibrations, vibrating strings. So I will start with that. In fact, I need 6 lectures for it, so that's quite a lot. But I would like to go, yeah, very slowly from deriving the equation of motion, finding natural frequencies, to in the end free and forced vibration. So I will do this step by step. So let's do that first. 6 lectures coming up. And after that, I will introduce you to the next topics, which will be about bars, shafts, and beams. All right? So if you like the previous lectures, I hope you stick around for this final series on continuous systems as well, and I hope you enjoy it. Thank you very much for watching, and I will see you next time. Bye-bye.